Hello everyone. Today I'm going to describe my parametric studies, that is, to analyze the behavior of a slab by changing the position of an opening.
Here are my main objectives, that is to compare the nodal displacements and to compare plate center stresses. So this is the input of my parametric study. I have taken a slab of dimension 5 by 5 meter and the whole location is firstly at center 1 by 1 meter and then at a distance of 1 meter from the corner. And the beam size I have taken is 0.3 by 0.3 meter and the column size is 0.5 by 0.5 meter. So we will start by opening STAAD Pro. Now open new file, fill the file name and select create option. Click on geometry option. Now click on grid. Now go to beam grid. Change view to front view. Now create frame of height 3 meter and length 5 meter. Create frame by transitional repeat command. Now generate meshing. Now click on quadrilateral meshing. Divisions. Create holes by deleting plates at the center. Now assign properties to beams and columns as 0.3 by 0.3 to beam and 0.5 by 0.5 to column. For assigning material, click on material and create it. For creating material of M25 grade, change the title as M25 and fill various parameters like Young's modulus, density and compressive strength. For Young's modulus, formula is 5000 under root FCK. Here FCK is 25 Newton per mm square, which comes as 2.5 into 10 raised by 7 kilonewton per meter square. Density of concrete is 25 kilonewton per meter cube. Now click on Assign to View. Go to Properties and assign the material to the cross section.
For assigning dimensions to beam, click on Select and choose beam parallel to X and Z, then assign dimensions to them. For columns, select beams parallel to Y and assign dimensions. Now add plate of thickness 150 mm. Next step is creating supports. Here we create fixed support, then assign it. Then comes the loading. In loading we take dead, live and seismic loading. Firstly we have to define seismic loads, and for that refer to IS code 1893-2016. Now choose code and generate. Fill the data such as city name, zone factor, response reduction factor. Here I choose the city as Ludhiana. Choose building as commercial buildings. Then apply. Then OK. Create self-weight factor. Inside seismic load definition, create self-weight factor as 1. And member weight is calculated by multiplying density of brick, height of brick and height of story. Now add and close. Now click on Assign to View. Next is load case detail. Add seismic load cases. add dead load and live load. Under dead load, I have considered self-weight. Under live load, I have considered plate load. I have considered my slab for industrial structure. So for that, as per IS code 875 part 2, live load for working area with machinery of medium duty is 7 kN per meter square. Then create load combinations. Now assign them and create load combinations. Click on Analyze, then Define and run analysis. Go to post-processing and record the responses. Now in part 2, everything is similar. Earlier the hole was at center, now the position of the hole has been changed. Now we have moved it to a distance of 1 by 1 meter from a corner. Click on Analysis, then Define and run analysis. Go to post processing and record the responses.